All right, this lesson is over quadratic functions. So this section 3.1, we're going to split into two parts. So today we're just going to talk about graphing a quadratic function using transformations. And then next time we will talk about graphing quadratic functions using the vertex and the line of symmetry and that sort of thing. But we're going to start by graphing a quadratic function using transformations because we've already done some work with transformations. Last unit we did a lot of practice transforming all of the different kinds of functions, and today we're just going to focus on quadratic functions, go a little bit deeper and do a little bit more with it. Okay, don't forget also that there is a handout that goes with this. I put on Blackboard a blank copy of the PowerPoint presentation so that you can print it out and write on it as you're watching the video if you would like. So just print it two pages per slide, and then or 2 slides per page, and you can follow along if you would like to do that. That is your option. Okay, so just as a quick refresher, quadratic function is a function of the form f of x equals ax squared plus bx plus c. A, b, and c are real numbers, and a will never be equal to 0. Okay, so we've seen this before. This is the standard form. For a quadratic function. We also have vertex form of a quadratic function, which is f of x equals a times the quantity x minus h squared plus k. This should look very familiar to you because we just used this in the last chapter to graph using transformations for all different kinds of functions. So this is specifically called vertex form for a quadratic function. So typically, when we were graphing with transformations, you were given the equation in vertex form. However, typically you usually see our equations in standard form. So we need to be able to find a way to still graph using transformations even if we're given the equation in standard form first. So a quadratic function can be written in vertex form by completing the square. So all that practice that we've been doing with completing the square, we can use that to get a function in standard form into vertex form. So we're going to graph the following function using transformations. Then we're going to find the x and y intercepts of the graph. So first thing we need to do is, if we're going to use transformations, we need to make sure that our equation is in vertex form. Otherwise, we don't know where the graph shifts up, down, left, or right, or if there's a stretch in it at all. So we need to get in vertex form so we know our a, our h, and our k. So the way we do that is by completing the square. So we're going to start with our function. I'm going to rewrite it. F of x is equal to negative 3x squared plus 12x plus 1. Remember, the first thing to do is always to get this c value on the other side. This is where it's going to be a little bit different from before. When we were completing the square before, our function was equal to 0. Now it's equal to f of x. So you cannot forget about that f of x. So on the left side, we're going to have f of x minus 1. As we subtracted that 1 on both sides, but since the left side's not equal to 0, we have f of x minus 1. We know we're going to add something to that side, so we'll put a little blank there. Negative 3x squared plus 12x. Okay. Actually, let's wait and do that on the next one, because there is one more step that we need to do before we complete the square. Also, we know that our a value has to be equal to 1 in order to complete the square. So this is where we're going to want to factor out that 3, not divide everything by 3, because it's no longer equal to 0 on both sides. We have that f of x over there. So dividing by 3 just complicates things. So we're just going to factor out that negative 3 to the outside because we're going to need that number later. So we're left with x squared minus 4x plus whatever we're going to add there to complete the square. So remember we have b over 2 squared. So in this case, negative 4 divided by 2 squared, which is negative 2 squared, which is 4. So we're adding 4 to this side. But don't forget, this is in the parentheses, so we're also multiplying that 4 by negative 3. So I'm going to add a negative 12 to the other side. So on the left, we have f of x minus 13 equals negative 3 times x minus 2 squared. So we'll go ahead and factor that trinomial. Factors to x minus b over 2 squared. Remember, we're wanting this in vertex form, so we'll go ahead and add this 13 back over to the other side. So I have negative 3 times the quantity x minus 2 squared plus 13. So here, now you can see that we have it in vertex form. So by completing the square, we can get it into vertex forms. Why that negative 3 was important to keep on the outside, because that is now our a value. That's our stretch. So our a value is negative 3, our h is 2, and our k is 13. So we're going to have our vertex at 2, 13. Then I'm going to make my parent function, my rate of change table. So this is a quadratic, so negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. So I'm going to change my rate of change. So I already have my vertex. I already took care of my vertex. So to the right 2 and up 3. So now my a value is negative 3. So I'm going to multiply all my y values by negative 3. So this is my new rate of change. So from the vertex, I'm going to change negative 2 on the x's and negative 12 on the y's. From my vertex, now I'm going to change negative 1 on the x's, negative 3 on the y's, 0, 0, so that's my vertex, don't move anywhere. Then from the vertex, I go positive 1 on the x's, negative 3 on the y's. Then from my vertex, positive 2 on the x's and negative 12 on the y's. Oops, forgot I have my fancy. There we go. There is our quadratic. So we started in standard form, but got that into vertex form using completing the square, so we could graph using transformations. All right, so now it asks us to find the x and the y intercepts of the graph. So the y-intercept is pretty easy. If you look at our standard form equation up here, finding the y-intercept, we're just plugging in 0 for x. So 0 squared times negative 3 is 0. 12 times 0 is 0 plus 1. So my y-intercept is always my c value when my equation is in standard form. So we can go ahead and I'm going to say the y-intercept was 0, 1, since 1 was my c value in standard form. Okay, so always the c value since we plugged in 0 for x. To find my x-intercept, I'm going to use my vertex form. Because if I use standard form, you're going to eventually have to complete the square anyway to solve. And we already did all the work for completing the square to get it into vertex form. So we're going to start with our vertex form equation. And when we're trying to find the x-intercept, we plug in 0 for y. So 0 equals negative 3 x minus 2 squared plus 13. So now all we have to do is solve and get x by itself. Don't multiply it all out, because then you're going to have to refactor or recomplete the square. We already did all the work for completing the square. So just undo, work backwards. So we have square root of 13 over the square root of 3 equals x minus 2. This is positive, negative. Okay. So we have, add the 2 to both sides, so we have 2 plus or minus the square root of 13 over the square root of 3. Now, recall from Algebra 2 and from earlier that we can't have a square root in the denominator of a fraction. So we need to multiply by the square root of 3. We're rationalizing the denominator so that that cancels out the square root in the denominator, because the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So that cancels out in the bottom, so I just get 3, and I no longer have a square root in the denominator. So then we just have the square root of 13 times the square root of 3, which is the square root of 39. So x is equal to 2 plus or minus the square root of 39 over 3. So we can write that as a point. So x is 2 plus or minus square root of 39 over 3, comma 0. So that is my two x-intercepts. Okay, so my y-intercept, 0, 1, and my two x-intercepts, 2 plus or minus the square root of 39 over 3, comma 0. All right, the next thing we're going to look at is, let's say we are given the vertex of a quadratic equation and a point that it passes through. So we're going to determine the quadratic equation in standard form, whose vertex is 4, negative 1, and passes through the point 2, 7. Then we're going to graph that function. So we're given in this problem the vertex, which gives us the hint that we're going to use vertex form first. Okay, it does say that we want our answer to be in standard form, but we can always start in vertex form and then put it into standard form. So vertex form, a times the quantity x minus h squared plus k. So when we have a equation in vertex form, I should have a number for the a number for the h, and a number for the k. The x stays a variable. So I know what my h and my k are. That's given to me, h and k from my vertex. So what I need to find is my a value. So let's plug in what we know. We have f of x is equal to a times x minus 4 squared minus 1. But if I need to find my a value, if I need to solve for a can be my only variable in the equation so that I can manipulate it and solve. Right now I have an x and I have an f of x, so I can't really solve for a. So if I want to figure out what a is, I need to find something that I can plug in for x and that I can plug in for y so that I have a as my only thing to solve for. Well, in the problem, it gives us that the quadratic passes through the point 2, 7. So there's an x and there's a y that I know are going to be part of this parabola. So it's specifically on this parabola, so I can use it as a part of the equation. So I'm going to plug in 7 for y. I still don't know my a. Plug in 2 for x. My h is still 4, and my k is still 1. So now I can solve for a, since it's my only variable. So add 1 to both sides. 2 minus 4 is negative 2. square that. Negative 2 squared is 4. So I have 8 equals 4a. Divide by 4, and I found out that a is equal to 2. So now I know my a value, I know my h value, and I know my k value. So I can write it in vertex form. Since the problem asks us to write it in standard form, now I want to multiply that all out so I can get it into standard form. So f of x is equal to 2 times x minus 4 times x minus 4. So I'm squaring that. X squared minus 8x plus 16. Need to distribute that 2. And finally, subtract the 1. So my standard form would be 2x squared minus 16x plus 31. So we started in vertex form since I was given the vertex, but then we can manipulate that, multiply it out so that it's in standard form. All right, let's go ahead and graph this. Easiest way to graph this, we know what the vertex is. So we know the vertex is at 4, negative 1. They also give us another point on the graph, 2, 7. Now remember, a parabola is symmetrical. So if I know I have the point 2, 7 on there, I'm also going to have the point over here at 6, 7. And there's your graph. So again, determining the quadratic equation in standard form when you're given a vertex and another point. Start with vertex form. Use that point to plug in so you can find your a value. Once you have that, then you have a nice vertex form equation. Take that vertex form, multiply it all out so you get standard form. All right. We're just going to do one more example of graphing the following function using transformation. So we're going to practice one more time by completing the square and getting it into vertex form and graphing it, then finding the x and y intercepts. If you felt really, really good about that first example, it is fine if you don't do this one with me. I'm going to also put a couple of practice problems at the end that are optional that you can practice if you feel like you needed a little bit more practice with it. Okay. So here we go, graphing the following function using transformations. We have f of x is equal to negative 2x squared plus 6x plus 2. So the first thing that we're going to do is, since we want to use transformations to do this, my equation needs to be in vertex form. Remember, we can get it into vertex form by completing the square. So subtract 2 from both sides. Don't forget to you need to keep that f of x there on the left side. The f of x cannot disappear. That is still part of the function. So it's f of x minus 2 on the left side. So we know eventually we're going to add something to both sides. I'm going to put a little space for that here. But I need to factor out my 2, my negative 2, because the x squared, your a value has to be 1 to complete the square. So factor out your negative 2, and you get x squared minus 3x plus whatever we need to add to that side. All right, so we have b divided by 2 squared is what we're going to add to both sides. Okay, and so my b value is negative 3, dividing that by 2 and squaring it. So I get 9/4 that I'm adding to both sides. 9/4 to this side, but don't forget that I'm adding 9/4 inside the parentheses, so I need to multiply that by negative 2. So I'm adding negative 9/2 to the other side. All right, we have f of x is equal to negative 4 halves minus 9 halves. So we need a common denominator to subtract. And we can factor our new quadratic now on the other side. So it's always x plus b over 2. Since my b is negative, it's going to be minus 3 over 2 squared. F of x is equal to negative 13 over 2. Oops, not what I wanted. F of x minus 13 over 2 is equal to negative 2. X minus 3 halves squared. Since we just want this in vertex form, we're not solving or anything like that. I'm going to add my 13 halves to the other side. So f of x is equal to negative 2 times the quantity x minus 3 halves squared plus 13 over 2. So my vertex is 3 halves, negative 13 halves. Okay. So now that we have it in vertex form, we can graph it. We know that our vertex is at 3 halves, and I'm actually going to, okay, so 3 halves, so 1.5 and 13 halves, which is 6.5. So 1.5 and 6.5 is my vertex. Go ahead and make that rate of change table. So change of x and change of y. Negative 2, negative 1, 0, 1, 2. This is a quadratic, so this is always going to be our parent function. And my a value is negative 2. So I'm going to multiply all the y values by negative 2. So from my vertex, I now have a new rate of change. From my vertex, I'm going to go negative 2 on the x's and negative 8 on the y's. So negative 2, negative 8. Then I'm going to go negative 1 on the x's, negative 2 on the y's. And positive 1 on the x's, negative 2 on the y's. Positive 2 on the x's, negative 8 on the y's. And there is our parabola. All right, let's go ahead and find our x-intercept and our y-intercept. Remember, the y-intercept is always the c value when you're in standard form, because if I plug in 0 for x, I'm just going to get 2. So I get my y-intercept is 0, 2, since I just plugged that 0 in for x and got 2 for my y. My x-intercept, again, we're going to use vertex form. Since we already did all the work for completing the square, we don't want to have to do that again. So plug in 0 for y. And solve for x. So we have subtract 13 over 2 from both sides. Divide by negative 2. Since I have a fraction over here, dividing by negative 2 is the same thing as multiplying by the reciprocal. So I'm going to multiply the other side by negative 1/2. So I have 13 over 4 is equal to x minus 3 halves squared. Take the square root of both sides. Square root of 13 over 2, positive and negative, is equal to x minus 3 halves. Add that 3 halves to both sides, and I get 3 halves plus or minus the square root of 13 over 2 is equal to x. So my two x points, you can either write them together or separate. So I have 3 plus or minus, please, Let's do it separately this time. 3 plus the square root of 13 over 2, comma 0, and 3 minus the square root of 13 over 2, comma 0. So again, you can write them together or you can write them separate, but you need to make sure you have both of your x-intercepts written as points. All right, so that's what we're going to be working on in class next time. If you need a little bit of extra practice, go to Interact Math and try doing exercise 27 and exercise 53 on your own. And this is a really great way to practice because if you feel like you're kind of iffy on what we just did, Interact Math will help walk you through that. It will give you the answer to it so you feel a little bit more confident before coming to class. And we will practice this when I see you in class next time.